Now let's see what is the classification of differential equations. This is important because the classification is going to tell us how difficult or easy it is to solve a differential equation. Let's start with the first classification. We have a partial differential equation and we have ordinary differential equation. Okay, as the name says, the partial differential equation contains partial derivatives, and the ordinary differential equation contains derivative of a single variable. Alright? So here the y is a function of x. The solution that we are going to find here is y as a function of x. While here the solution that we are going to find, we will try to find is a function of two variables, x and y. Okay? The function of phi. Now, for this course of differential equations, we are not going to cover this kind of partial differential equations. They are way too difficult to solve. We will need another semester, and not only one, but several semesters. But what we are going to do in this course is solve ordinary differential equations. All right? Those are for this course. Okay, so that is the first one, the type of differential equation. The second definition is by order of the differential equation. Well, the order differential equation is, it means how many derivatives the equation has. How many derivatives the differential equation has. By the way, I forgot to mention that I'm reducing differential equation as just DE, differential equation. How many derivatives the differential equation has? Well, that is the order of the differential equation. Let's write some examples. For example, let's say this example from the previous video, derivative of y respect to x equal to 2x. Now this differential equation, second derivative with respect to x squared plus, or well, in this case minus 3, derivative y respect to x equal to the natural volume of x, or let's say this y 7 derivative respect to y respect to x 7 plus let's say exponential of x equal to the sine of x. Okay, now the order of the differential equation is the number of derivatives, but be careful here. This one is first order differential equation. This one is second order differential equation, and this one is seventh order differential equation. Now, don't count the number of derivatives. Here you may think this is third order because you have 3 derivatives. No, the definition of the order is just the higher number of derivatives. So here is 1 derivative, and here is the higher second derivative, so it is second order differential equation. Here the highest is 7 order differential equation. Okay, now why is important this classification? The higher the order, the more difficult to solve. The lower the order, the easiest to solve. So I'm going to write like this, easier, and from that, harder to solve. Easier to solve and harder to solve. Okay, by the way, on the first unit, we are going to cover first order differential equation, and the second unit of this course we are going to cover higher order differential equation. Alright, so this is the type of order. Now, the third classification is very important, is by power or degree. You may remember this in Spanish as la potencia. In this case, the power is the power that has y, comma, derivative y respect to x comma, second derivative y respect to x, or n derivatives of y respect to x, n. So the power that has y and its derivatives, alright? So the power is different. If you remember this as the power, maybe you remember like this. This is the first degree, and this is second power, and this is the third power, or third degree. But only applies to the y. If you happen to have x to the power of 6, that doesn't count. The power or degree only applies to the y or the derivatives of y respect to x. Okay, just to give an example, this one, the previous example, derivative y respect to x equal to 2x. So this one is it is first order differential equation, but also is first degree. Okay, let me give another example of, for example, derivative of y respect to x equal to 2x, but here I'm going to make this a square. Or another example, derivative y respect to x plus 7y to the power of 3 equal to x to the power of 4. Okay, those three examples. Now, this one is very easy, first degree. It is first degree because the derivative of y has power 1, so that is why it's first degree, but also is first order. Now, in this case, this example is second degree. It is first order, but it is also second degree. And the degree is given by the square here on the derivative of y respect to x. Now this one, it is first order, one derivative, first order differential equation, but also it is, here is third degree. The reason of the third degree is this number 3. You may think it is 4th degree. No, because this 4 is applied to the x. The degree is only with the y or the derivatives of y respect to x. X can be anything. You just be concerned about the y. Okay, here, just like the previous one in the order, similar, the higher the degree, the more difficult. The lower the degree, easier to solve. Easier to solve. Difficult to solve. So that is why it's very important to know the order and the degree, because it's going to tell you how difficult it's going to be. Again, higher the order, more difficult to solve. Higher the degree, more difficult to solve. All right. So this covers the classification. Just to remember one thing, this also. Just one more thing, I'm going to erase this part. Well, I'm going to just to say it, all the differential equations that are first degree are linear differential equation, alright? So we will see that concept of what is linearity. If they happen to be first degree, then it is most likely to be linear. So this is the classification of the differential equations. See you on the next video.